Okay, now in this segment, we're going to first see that what do we need to actually get this surface. So before that, the basic idea is that we need a flat unstretched surface. That means either through loft or through edge surf, anything. We just need a surface or a poly surface that kind of looks but something like this but straight. How do I do that? I'm going to go to plan and I'm going to make some points. Again, most of my examples work with points and lines. So I'm going to make 4 points randomly right now. And I'm going to also lift them up because these points are lifted in the air. So what I'm thinking is 4 points here and 1, 2, 3, 4, 5, 5 points on the arc. Okay, so I'm going to lift them a little bit up. Okay, and I'm going to make a polyline. Okay, and I'm going to choose 5 points right now randomly from this truss. So I have, sorry, yeah, I think, no, let's do it once again. Okay, so I have this polyline and I have this polyline. The next thing is naturally to loft it, and this is the basic crux that if you are, I'll just put it okay, simple. If you're able to achieve this, okay, then from this to this is pretty simple. We have to convert this into a mesh, uh, adjust the mesh and feed it into Kangaroo. So okay, you've got this truss, you've got these points, made lines, made a poly surface. You cannot rebuild it because it's a poly surface. So let's make it a mesh. Poly surfaces are also known as boundary representations of B-reps. So I'll just feed this here and I'll feed this into a B-rep mesh. Now mesh is important because surfaces itself, they don't really work with physics simulations. In this case, the physics simulation is the idea of stretching the fabric, right? So it works better on a mesh. So B-rep mesh converts B-rep to mesh. I feed it here and nothing really happens, but you can see that if I take out mesh edges, you'll see that kind of looks like a mesh, although a little ugly. But let's look at this scary little component. I'll use custom settings and looks very scary, but what are we trying to do here is only what is the maximum size and what is the minimum size of the edge, and we'll get to this in a bit. Let's say 200 mm and 2 meters. Let's put a crazy range, and so we are feeding this into a B-rep mesh, adjusting the sizes and then seeing what happens in the B-rep mesh edges. So this goes into the minimum and this goes into the maximum, and you will see that there's a bigger range. So the mesh edges, I'm going to hide this and I'm also going to hide this, also going to hide this, yes, and see what's happening. These are the mesh edges. Okay, now if I put this bigger and this smaller, kind of looks like this, and this looks pretty neat. We want as squarish meshes as possible. Now this looks fine. This spiny range kind of works. If it doesn't work, one or two are not triangles, that's still okay in your case. But we need just for better physics simulation, we can triangulate the mesh. And so you'll see it in a bit. If I introduce this and I feed this here, you can see that earlier this was a quad mesh, but if I feed it in triangle and extract the edges, the mesh edges, you'll see this very, very beautiful mesh. This is almost ready to be fed into Grasshopper, sorry, in Kangaroo. Okay, now moving ahead, just for revision, we got points, we made the truss. The points, we got some more points to get this other corners, because this has 1, 2, 3, 4 on that side. You can see the shadow and some more points. We lofted it, made a surface, fed that surface into B-rep, that goes into B-rep mesh, and the mesh edges that we are trying to change here with these settings. And then finally we triangulate it to kind of get these into tiny triangle faces. So we have all that, we have all the points as well. Now what Kangaroo does is, Kangaroo is this, somewhere you can find K. Kangaroo takes three things. There is a solver. The solver is the simulation engine, and it takes three things. First is the anchor, which is 1, 2, 3, 4, 5, whatever these points. it takes the mesh itself or the edges of the mesh, let's call it M. Okay, and it takes a button, a toggle button, switch on and off. These three things, that's all. It's a very, very simple simulation itself. Let's see. I'll just keep it on the side. I'll see solver, and you can have many solvers, but my favorite is this bouncy solver. Bouncy solver gives me a lot of these iterations while it kind of changes its simulation. So I like the bouncy solver. They're all the same. And bunch of solvers here. Okay, under Kangaroo, I'll use the bouncy solver. Uh, Within the goal objects, I'll take anchor. These are all components within Kangaroo, and it takes a point. So I'll feed the 9 odd points manually. 1, 2, 3, 4, 5. This is the point where you have to kind of put it manually. I don't know why there is doubling. By the way, let's do one thing. Let's start this. I will just use cell dump, which selects my duplicates. Okay, apparently I made it a couple of times and I'll delete it. What that does is I just deleted any kind of duplicate instances of any geometry. So anyway, now my task becomes easier. I go to point, select these 9 points for my anchor. You might have more depending on your design, and I'll feed it into point. This point goes here. Now there is one last thing. It's called edge length. Now this icon is interesting. Sorry, it's called mesh length. Nope, it's called edge length. Yes, this icon is interesting because it kind of looks like a tensile structure in itself. It's a blue icon and it takes the mesh. Okay, and it's basically taking these lines from the mesh and it's going to stretch it, and we'll see in a bit how. I'm going to hold shift. I'm going to feed it here. Okay, nothing really happens because this length factor is 1. Basically, if you have 2 points and the length is 1 meter, nothing will happen for this rope which is 1 meter. But if you take a 0.8 meter rope within 1 meter distance, you will have to stretch that. Okay, so the idea is to take a length factor smaller than 1 so that you can stretch. Basically, you're taking less cloth in that anchor and then you'll have to stretch. Otherwise, there won't be any stretching. Finally, I'm going to use a toggle in reset. False means off, false means on, true means on. True means on because, okay, we'll see in a bit. Let me do talking less. Let me set this to true. True means it's resetting every moment. So I'm going to put it true, and I'm going to put this as 1. Okay, and you'll see nothing will happen. I will hide all of this. You will only see this, and you'll see nothing has happened if I put this to false because I'm taking 1 and I'm spreading it but 1. I'm not changing the length factor. But if I take this down, you'll see this magic happen. I've seen somewhere around 70 to 80% of the original length, that is 0.7, 0.8 length factor, works nicely. Okay, so this is fine. That's all. I can bake the output. This is O. I can bake the output, and better if I kind of group it because there's too many lines. And once I bake it, I'm going to close it, and then I can use mesh lines. This is a fantastic command that was introduced in Rhino 7. So I can generate a mesh from these lines, and you'll see in a bit. This is the surface. Okay. If you want to get it into a rendered view, you can see that I can always hide the lines. These are my open curves which are grouped. I can hide them. You can see that it kind of looks like this tensile structure in any of these other views. I think Arctic, yeah, kind of looks like a tensile structure, but the best is somewhat like this. You can always render it, but that's as easy as it gets. This is the code, that's all. Okay, you took the original surface. Let me get that back. through lofting, fed that into brep. Let me hide it. This brep made it a mesh. We triangulated, nothing is visible, but if you switch it on, you can see the original mesh. Okay, this is just for visualization. You don't really need to have any output out of this, just to make sure you're gauging the sizes correctly from this. And after that, we get into the Kangaroo territory. It's rather small. I take the actual anchor points from this mesh that I've created, which is this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. I feed it here, these 9 points. Like this. Feed it into anchor, feed this mesh directly here, and then I switch it back on. So this is what's basically happening, and this is what I like Bouncy Solver, because you can see that movement of that, that thing that is happening. It's basically a mathematical simulations, mathematical computations happening within milliseconds, so that it's trying to stretch and get that optimum size. I can always change it. It goes really crazy for smaller size. Let me hide this as well. It goes really mad. Nothing wrong with this, but this is too much stretching in my opinion. But somewhere around 70% it works really nicely. So yeah, this is what this looks like. And then you can always bake it. Since I've baked it, you can always mirror it. This is around the central point. That's all.